Okay, so today we are going to be doing section 1.4. Actually, we're going to be covering two sections. Now, those sections will be broken into two different sets of videos, but we're going to cover both sections in this class. 1.4 and 1.5. So, we had this blob. We found its center. We found how spread out it was. Last time we said, okay, if I look at this little piece of the blob, where is it in relation to this piece? Today, it's all going to be about the shape of the blob and how to, by hand, get a rough idea of what the blob actually looks like with pictures. So first off, the shape. What is the shape of this blob? All right. So what does that mean? Well, when I originally did this section, I had two different measures of shape. I eventually dropped one of them because mathematically it was somewhat challenging and it's not that important of a statistic. So I did drop it. So we only have one measure of shape for this section, which is skewness. And it's going to give us an indication of if the data is symmetrical or not, and if it's not, which direction it's not symmetrical in. So, for example, if we have this huge blob, and then there's a few things over here that pull the blob out this direction, we say it's skewed. And which direction is that skewed in? So that's what this value of skewness is going to tell us. If it's 0, the value is 0, it's symmetrical. If it's negative, we're going to have a tail of the blob going this direction. If it's positive, we're going to have a tail going in that direction. The calculation for this is very similar to the calculation for the variance or the standard deviation. It's just a little bit more challenging. All right, so let's talk about skewness. A distribution of scores is skewed if it is not symmetrical and extends more to one side than the other. A distribution of scores is symmetric if the right and left paths are roughly mirror images of each other. So if I take, for example, this table, if this is my distribution, right, and the center is right here, if I could flip this table over, it's going to be the same on both sides. This is symmetrical. It doesn't have to look any specific way as long as it's the same on both sides. Now, if this table had a leaf that came out and the leaf went out this way, and like on a diagonal or something, then this would be skewed to this side because it's not symmetrical anymore. All right. Skewness is the measure of asymmetry of a set of scores. It can be positive, indicating that the right tail of the distribution of scores is longer than the left, or it could be negative, indicating that the left tail is longer than the right. So let's specifically look at a couple pictures of this first, and then we'll come back. So these are examples of what I'm talking about. So this is a bell-shaped distribution that's symmetrical. If I cut it in half, flip this over, it's the same on both right and left sides. This one here is negatively skewed. This tail is drawn out this way, so it is negatively skewed. This one's tail is drawn out to the right. This is positively skewed. All right, these things are called the tails. These little things that come out like this. Now, remember, we just happen to be using a distribution, a graph that looks like a bell. This could be a square. It could be anything, but if we have part of it that goes out further one way than the other, it's skewed. All right, so let's look at specifically negatively skewed and positively skewed. So, negatively skewed, that's this one. Data is skewed to the left. What does that mean? That means the extreme values are in the low end of the spectrum. So if this was house prices for a town, most of the houses are relatively the same price, and we have some cheaper ones. some shacks or something. Whereas if it was positively skewed, we have some mansions that are coming up here. Second thing, the value of the mean is less than the median. So remember, when we talked about this before, as this tail starts to grow to the left, it's going to pull the mean with it. In this case, as the tail goes out to the right, it pulls the mean to the right with it. The median is relatively going to be stable. It's not going to move. So if my median is here, yeah, if a lot of the scores get pulled out, it's going to move some, but it doesn't move very much. So the mean is really going to get pulled out further than the median. So in this case, negatively skewed, the mean is going to be less than the median. So, a newspaper article talks about the selling price of houses in Pittsburgh. The mean selling price in Pittsburgh was $200,000. The median price was $250,000. So the mean is less than the median. Therefore, this is what your distribution is going to look like. It's going to have a left tail, which means the extreme values are in the cheap end homes. All right, and then there's a spider that is descending upon the lecture here. Okay. So the majority of the scores lie to the right of the mean. So think about this. If these scores here pull my mean out, and if this is a swim, let's imagine this is a swimming pool filled with water, all the same depth. If my mean gets pulled out here, there is more water on this side than there is on this side. So more of the water is to the right of the mean. So when we have a negatively skewed distribution, the tail is going to go to the left. The mean is going to be less than the median. Now, there are times that that is not true. It is possible to have a mean greater than the median. It is very, very rare, and chances of you running into it are very slim, so don't worry about it. But for the sake of this class, the mean is less than the median. It's negatively skewed. And the last thing is that more of the scores are going to fall to the right of the mean than to the left if it's negatively skewed. Positively skewed. Data is skewed to the right, so in other words, my right tail is longer. The value of the mean is going to be pulled by this tail, so it's going to be greater than the median. And the majority of the scores fall to the left of the mean. All right. So any questions on just the general concept for this? This is a common occurrence to have things that are skewed. A lot of times in the real world, random fluctuations, yeah, they do look like this. But a lot of times they don't. For example, later on in the semester, we're going to spend a lot of time talking about hypnosis and people's suggestibility levels for hypnosis. If any of you have ever been to a stage hypnosis show, you know that out of all the people that go up, depending on how this hypnotist does it, very few people actually stay up there. So if we look at the general population's suggestibility level, it looks like this. Most people are down in the low end. Very few people are extremely suggestible to the point of being able to, say, do surgery on them without anesthesia or something like that. However, that is not to say that these people cannot have a strong beneficial gain from it. So a number of years ago, there's a radio station here in Rochester. Warm. Wow, awesome. I was on that with their DJs in the morning. They have this competition to guess what the person's job is. So they had me on. Now, I wasn't a hypnotherapist. I do hypnotherapy as a tool in the other stuff I do. It's not what I do for a job, but they wanted me to pretend that's what I did for my full-time profession. So they had me on, and they did the whole guess the person's job thing. Well, it was a disaster because someone I knew heard my voice and knew it was me and called in and said, "Oh, you're a hypnotist or hypnotherapist." So it was kind of a disaster. But what they had me do is, after that, is they had me hypnotize the male DJ that was on there. He ate donuts all the time, constantly ate donuts. And he didn't like the fact that he ate donuts so much. He had a donut addiction. So he asked me to come in and hypnotize him to stop eating donuts. Well, I didn't want to do it over the air, because if someone is extremely suggestible down in that far end, can you imagine if they're driving and all of a sudden they enter a trance and they just like fall over? I mean, that's no good. So I said, okay, it's got to be off the air. I'll hypnotize you. You can come back and can talk about it. So he and I went in this other room. Now this guy is like, wired and shaking and all energy and all that, because he eats a lot of donuts and a lot of coffee. So just the fact that he has all this, the chemicals in him and the sugar was not good.